Hello and welcome to traditional projectile motion problem. In a traditional projectile motion problem, you're given two pieces of information. The information you have is the same information that you get to control when you play, let's say, Angry Birds. You get to decide how fast this object is traveling, right? The speed at which it's traveling. Right? The further you pull the Angry Bird back, the faster it's going to go. Also, you get to decide its angle. Right? You get to decide the angle. Do you want to shoot it high or do you want to shoot it flat? So what we're going to do is we're going to call the speed v, standing for velocity, sub 1, meaning it's its first velocity, it's its initial velocity. Let's say that we shoot this soccer ball at 100 meters per second. That's going to be the speed at which we're shooting it. And let's say that we shoot this object, this soccer ball, at, let's say, 30 degrees. 30 degrees. So here we go. A soccer ball getting kicked at 30 degrees. The ultimate goal is to figure out how high the ball is going to go, how far it's going to go, how long it'll be in the air. Those type of things. All right. So the first thing to do is think about what you know. We know the initial velocity. We know the angle. We also know, by default, the acceleration is negative 9.81 meters per second squared. And that's about it. Now, let's first start by trying to find how far the object is going to go. How far it's going to go is going to depend on how long it's in the air and how fast it's traveling horizontally. So we first need to find how long it's in the air. In order to find how long it's in the air, we need to find how fast it's moving vertically. So what we're going to do is we're going to find the horizontal velocity and we're going to find the vertical component of the velocity. Now we're going to call the vertical component v sub 1 because it's the initial vertical velocity, sub y, meaning it's in the y direction. All right. So in order to find v sub 1 sub y, meaning the initial vertical velocity, we need to do some trig. We need to say that the sine of the angle that we know is equal to the opposite, which we don't know, v1y, divided by the hypotenuse, which we do know. Solving for v1y, we get v1y is equal to v1 times the sine, almost wrote cosine there, times the sine of theta. Now we can actually plug in and calculate. So v1 is 100 meters per second times the sine of 30 degrees. Now the sine of 30 should be exactly 1/2. So that would leave a vertical velocity of 50 meters per second. All right, that's how fast the object's moving away from the ground. Right, it's the speed at which its elevation is increasing. All right, so now we can fill in our chart. v1y is 50 meters per second. That's how fast it's going vertically. So with that information, we can now calculate how long, meaning how much time it's going to spend in the air. Right? The faster something's moving upward, the longer it's going to be in the air. That should make sense. So in order to do that, we need to use the theory that acceleration decreases a velocity by 9.81 meters per second every second. So in order to do this, we use the equation. Acceleration is equal to a change in velocity divided by a change in time. Now specifically, we're going to be looking for the change in time to the peak. And that's going to be equal to the change in velocity to the peak divided by the acceleration as it's rising to the peak. So let's bring this down one step further. The change in velocity to the peak is going to be the final vertical velocity minus the initial vertical velocity divided by the vertical acceleration. Now, what's the final vertical velocity? Well, we didn't necessarily note that, but we do know that at the peak of the trajectory, the final velocity is 0 meters per second. So we now can plug in our givens. We have a final velocity of 0 minus 50 meters per second divided by 9.81 meters per second squared. And so 50 divided by 9.81 is going to equal 5.1 seconds. 5.1 seconds. I'm going to box all the important answers. Okay, so there we go. We have now solved for time. We know this object is going to take 5.1 seconds to reach the peak. All right, it's not going to be in the air for 5.1 seconds, but it's going to take 5.1 seconds just to reach the peak. So, if we know it's going to take 5.1 seconds to reach the peak, 5.1, it's going to take another 5.1 to reach the end, so that's a total of 10.2 seconds. All right, the total time is twice the peak time. Okay, good. So now we need to figure out how far this object actually travels. And to do that, we must think that the motion of a projectile horizontally is constant. And we use this equation, that a constant velocity is equal to a change in distance divided by how long the object's in the air. Solving for displacement, specifically we're solving for the horizontal displacement, which we call the range, is going to be equal to the horizontal velocity times the total time it's in the air. So actually plugging this in, well, we didn't find the horizontal velocity yet. So let's solve for the horizontal velocity. And we're going to do that by saying the sine, oops, not the sine, it's going to be the cosine. The cosine of theta is equal to the opposite, which is the adjacent, divided by the hypotenuse. So that gives us Vx is equal to V1 times the cosine of theta. Plugging that in, we have 100 times the cosine of 30 degrees. 100 cosine of 30 comes out to be 86.7 meters per second. All right. So now with that information, we can now say that this object is going to travel 86.7 meters per second times 10.2 seconds. That's how long it's in the air. And when we calculate that, 86.7 times 10.2, we get 884 meters. That's a really long, it's a big soccer kick. All right, so that's the range of this soccer ball. That's how far it's going to go. Now we need to find out how high it's going to go. It's the last thing we need to solve. All right, so the height is going to depend on a few things. First, we need to fill this in. 86.7 meters per second and 884 meters. So the height is the only thing missing. So let's go ahead and calculate it. Now the height of the object, delta dy, is going to be affected only by the vertical velocity and the acceleration. We can find it directly from those two things. Let's think about our 4 equations of accelerated motion. The one that relates to velocity and acceleration is going to be this. Delta d y, the height, is going to equal the final velocity vertically squared minus the final velocity the initial velocity vertically squared divided by acceleration. Now, plugging things in, we get 0 squared minus 50 meters per second squared divided by negative 9.81 meters per second squared. All right, and when we calculate that, we do negative 50 squared divided by 2 times 9.81, and we get out 120, this is supposed to be divided by 2a. We get out 127 meters per second. Meters. All right, and that's it. That's how to find every element of projectile motion. Now, there's multiple ways to solve for the height. You could use the time and the acceleration to find the height using the second equation of the 4 equations, right? But that would mean you need to first find the time and then find the height. You can find the height directly from just the vertical velocity.